let's spend a little bit of time looking at the place where all these detritivores and decomposers live, the soil. It's a little bit of a detour from what we've been talking about. It's important though, because it's where these things spend their lives. So that layer of stuff, the dead stuff on top of the ground, do you remember what that was called? Something matter. Organic matter. Yeah, organic matter. So that's the first layer that we see. Underneath the layer of organic matter, we have something called topsoil. And that's where it starts to be recognizable as dirt, where you start to call it dirt. Not so much of this obvious dead stuff like these pine needles on top. Below the topsoil is something called subsoil. Sub, just like a submarine goes under the surface of the water, the subsoil is below the topsoil. Below the subsoil is something called the parent rock. So the parent rock is the broken up bits, the crumblies of the rock. Now, the parent rock has broken off of something and is part of something called bedrock. You've probably heard bedrock before. It's like the bottom layer of soil. It's kind of where the stopper is between all the rock of the earth and the soil on top where life grows. This rock behind me is limestone. I've mentioned limestone a couple times. In the Change Over Time video, it was the kind of rock where all the fossils were, and it was that big rock that I had my hand up against. Right? So limestone, right here, it's the parent rock of the soil because there's lots of broken up bits. What we're going to do, we're going to go to the lab in just a moment after I take a sample, and I'll describe that in a second, and we're going to look at the sample that I take, and we'll be able to see layers of the soil. So what happens is that whatever the soil is made out of, if there's lots of sand in it, lots of clay or something like that, it'll show up in this way that we can test the composition of the soil. It's a really simple process. It's a scientific thing, but we're going to not do it like you would in the laboratory. It's more of like science play. And we actually can learn a lot when we play. I had a professor in college. He was one of my favorite professors. His name was Dieter. He was German. And one of the best lines that he ever had was this: "When we play, we learn, yeah?" Here we are on the ground, ready to take our soil sample. You'll just need a few things. Obviously, the first thing you're going to need is some place to dig. The next thing you're going to need is something to dig with. I have a garden trowel. You might have a spoon or something, or of course you might have a shovel. Whatever is handy, and as long as you have permission to use it, it'll work. The last thing you'll need is a jar of some sort. Just make sure that you can close it up somehow, because later on we're going to add water to this and it might get messy. All right, taking my lid off, have my jar ready. First thing I want to do, clear away our organic matter, the big stuff I should say that's on the top. It'll get in the way, especially these pine needles. This stuff here, that's okay. We can work with that. But any kind of big, oh, here's a big stick. Any kind of stuff like this, look at it, you can see how it's crumbling, how it's being fragmented and decomposed. Big stuff just will get in the way of our jar, okay? Here, we're set right there. Scrape away just a little bit. And now I'm gonna dig down. I'm gonna loosen up. Oh, I got a rock right there. Oh, I got a big rock. Look at that. Of course, there's a rock in my way. That's okay. I'll go next to it. I'm just gonna go down however far I can. This is where the play part comes in and not the science part, because I'm not being very careful about how far down I am going. So here is a sample. If you find any guys living in there, Try not to scoop them up. Leave them. You can watch them for a little while, but leave them to their own life. All right. This is a good amount. All right. We can already start to see when it's up against the glass there, some different things that are in there. And look, I'm not sure what these are. See, look at that. We're playing, and what did Dieter say we were going to do when we play? We learn. All these little things. I don't know if they're seeds. I think they are seeds. They kind of look like bear corn seeds. Do you remember way back, the scat video? I showed you bear corn. They almost look like that. Kind of hard to tell. Interesting. All right. What else is in there since I'm here? I see some roots here. Another rock down there. Getting kind of, you know what? I can make an observation by feeling. On top here, these pine needles, they're dead and dry. They're brown. What do you think happens to the soil as I'm digging deeper? I can notice two things. One thing I notice is that there's moisture in there, not like a puddle of water, but just so it makes the dirt, the soil, sediment stick together in clumps. But something about the temperature changes too. Yeah, I think everybody's experienced that before. It cools off. It's nice and cool down there. It'd be a good place to have a tunnel on a hot day. All right, I'm not going to leave the hole like this in the forest. That's kind of obnoxious and rude, so I'm going to bury it back up. Let everybody that was doing business down there keep doing their business. There we go. All right, next stop is going to be our lab, where I'm going to mix some water with this and show you what happens. Back from the forest in our lab right now. Before we move on, I just want to make sure that it's clear what it is that we're going to be doing and what we've talked about. What I was talking about before, right before collecting the soil sample, was the layering of the soil. At the very top, we have all the dead stuff, the organic matter. Below that, we have what's called the topsoil. Underneath the topsoil is the subsoil. Then we come to the parent rock, the broken up rock, and then the bedrock at the bottom, the solid rock that the parent rock came from. That is similar, and it's related to what we're going to do right now, but it's not the same thing. What we're doing is taking, it's kind of a mixture of that, of some of the organic matter in the topsoil, because we didn't dig down really far. That's what we're going to be looking at, just that very top layer without all that dead leaves, with all the dead leaves and everything, and just checking it out, just to see what it looks like, and what type of stuff is in there, like clay and silt and sand and that kind of thing. So, here is that soil sample that I took. It's in that jar I showed you. Since we have some other things down here in the lab that you'll have at home, I just want to show you so that you'll understand you can pretty much use whatever. This is just a plastic container. This is perfectly good to use. Here is just an old jar that had green chili in it. Took the label off. The thing is, we need to be able to cover it, to close it up somehow. I know sometimes lids get tossed, jars get tossed separately, and then we lose the lid. If you just don't have a lid, guess what you can use? A bag. So you'll be able to put the bag over it and rubber band it like that. All it is to just prevent a spill from happening, just to keep it from getting too messy. Okay, so back to this. Here's our sample that we took out in the forest. I'm going to take the lid off. I'm going to put a little bit of water in there. Well, probably not just a little bit. Up to about here. Not all the way up to the top, because then it gets too messy, potentially. All right, it's not all mixed up yet. You can use a spoon or whatever. It's all mixed up. I can feel it down there. Stuff wants to sink down immediately. Other stuff's gonna float. So what kind of things are gonna sink down? Yeah, the heavy things like rocks and things like that. What we're gonna, and now that this one's really nice, tightly sealed, shake, shake, shake. I'm gonna shake it up. Just looks like coffee, doesn't it? This is gonna have to sit overnight, most likely, until you see some results. It's been a day now since we took our soil samples. Let's look at them. This one looks kind of yucky. We have a bunch of organic matter floating in here. Remember, because the ground had so much. And then we have the dirt at the bottom. The dirt is broken up into a few different layers. What I'm going to describe to you is the soil structure of this sample. The soil structure is how much clay, silt, and sand, and other particles like that are in there. So of course we have, like I said, the organic matter and the water. I see a very thin layer. It's light colored. It's the lightest colored in this jar. That thin layer is clay. The next layer, I can barely tell the difference between it and the rest of it, but I see it. It is silt. It's a little more coarse, which means the particles are bigger than the clay. And then near the bottom, we have mostly sand. Those are larger particles. So which is the lightest out of all this? The organic matter, clay, silt, or sand? Well, the organic matter, because it's still floating. Now, out of the dirt stuff, what's the lightest? The clay, because it's on the top layer, which means it was floating in the water the longest. And what's the heaviest? The sand, because it sunk right away. After you do this, check it out. I'd like you to record your results. Do you remember the observation log that you did with Vince for the change over time video? Well, it's observations, but it looks a little different. It's called soil structure. Soil structure is up at the top. And then sample 1, sample 2, sample 3, all depends how many you have. And then a description of what the area was like where you got it from. So real quick, this sample, sample 1, was taken from the Sandia Mountains. The area was surrounded by ponderosa pine trees and oak trees. There were many limestone rocks nearby and lots of organic matter on the ground, which describes why there's so much here. And then the fun part, at least I always think so, is the drawing. You're just drawing a picture of our sample. But importantly, you are putting labels to these different layers so that somebody else will know what it is that they're looking at. I drew and labeled the organic matter, and of course the water. The little fine, thin layer of clay is there, and I gave it some diagonal lines so it looked different. Then the layer of silt below it, I shaded it and put some speckles in it. And then the sand layer, I just put speckles. So everything looks different and unique from one another. We have a picture way of seeing the difference and the words. I also used a ruler and did a little bit of measuring just so I could get it fairly accurate for the thicknesses of these different pieces or these different elements in the soil.